Hello students, welcome to Lab 5. This is our penultimate lab. We only have one more lab after that. And at this point in the class, we're really trying to start to clean up the remaining concepts that you need to know to be a good data analyst or a data scientist. By this point, we've covered basically all of the basics, all of the tools that you will use in 100% of your projects. For example, you will always need to know how to get data into R or Python or whatever tool you're using. You will always need to know how to manipulate that data, and you will always need to know how to visualize that data. These are just kind of core things that you'll use in 100% of all of your projects. Now we're starting to move into tools that you'll probably only need in 60 to 90% of your projects. So some of these projects, for example, or some of these tools might be like pivoting. How do we get data from one format to another format? If you're used to Excel, you probably have a basic intuition of what pivoting does, but we'll talk about it a little bit more in the context of tidy data, the same tidy that gives the tidyverse its name. We'll also talk about iteration. Now, the way that we do our data analysis, if you can remember from our last lab, remember when we made a set of just numbers, we just multiply all of the numbers in that set by doing like times 2, right? And you'll notice for all of the analysis that we've done so far in the class, we've done it inside a mutate command, inside a filter command, inside a summarize command. All of those functions, we did it over all of the rows in a data set, and so we didn't really need iteration. Most of those tasks are kind of taken care of for us in a manner called vectorization, which is not super important. But there are some tasks that cannot be done all at once, that need to be done iteratively, and we'll look into one of those tasks today, and just so that you can kind of understand what iteration is doing. Once we're done with that, we'll talk about custom functions. So far, we've used functions that are provided by other packages, but there's really nothing special about those functions. If you wanted to, you could write your own functions that do special things. For example, the function that we'll look at today is how to center and scale your variable, and we'll talk about what that means a little bit later. But in general, you can have a function do any arbitrary thing that you can write in regular code, you can put it in a function, and then instead of retyping out the whole code every single time, you can just call the function. So they're very useful in simplifying your code, putting ideas together. And lastly, we'll talk about regular expressions, or regex, or regex, or whatever you want to call it. This is a way of kind of talking about strings and manipulating strings and pattern matching. So we talked a little bit about this in the lecture, but we'll go into a few examples. We might do the same example, we might do a different example. We'll see how it goes. So as I mentioned, before we jump right into it, these 4 topics are things that you might not need in every single project, but they're still really important for you to understand. So the great thing about learning kind of analytics is that as you gain more tools for your toolbox, tools like pivoting, iteration functions, and regex, over time you'll get faster and you'll get better and more creative about the types of analytics that you can do. So even if it doesn't seem like it's especially useful right now, believe me, in time, if you pursue this as a career path, you will likely find projects where these things come in very handy and they simplify tedious work or they enable very interesting analytics. So terrific. Let's get right into our code. You can see, as always, I've loaded the tidyverse and I've loaded the electricity data set. This is not the electricity data set that we worked with in the past. In fact, if you remember from the last lab or the previous lab, I don't remember, I said something along the lines of, I've done some minor cleaning of this data set. And today we're going to go and we're going to see what that cleaning looks like. So why don't we take a look at our data? And what's interesting is that you can see here that we have 2 of the same columns, country and code, but then we have a different column for every year. Now, if you cast your mind back to the last lab or the lab before that, or any lab where we worked with this data, you'll remember that we only had 4 columns. We had a column for country and a column for code, as we have here. But then we had a column for a year, and then we had a column for basically whatever value was in here, right? We called it electricity or education, depending on what variable we were looking at. That format of data, where we have one column per variable and one row per observation, we called that tidy data. That's what a tidy data set is. This is not a tidy data set because, in fact, we have information in column names. Tidy data is also known as long format data because if you can remember, we had something like 15,000 rows there. And even though we only had 4 columns, we had a lot of observations, a lot of rows. Here, it's kind of different. We have only 266 rows, 1 row per country, but we have 1 row per year. This is called wide format data. And you can see why it goes on and on and on forever. In fact, it has excluded all of these columns because it's in wide format. In fact, there are so many columns. This 3 dots down here tells us there are even more columns that I couldn't even show you that I didn't display. Right? 49 more variables. That's a lot. So how do we go from a wide format data to long format data? We can go the opposite way, but for now we're not going to worry about that too much. Luckily, the tidyverse makes this very simple for us. So, pivoting wide to long. As always, we're going to start with our data, and we're going to do a pipe. And by now you should be very, very familiar with that. After that, we're going to use a function called pivot longer. We're going to pivot our data from the wide format to the longer format. And what we need to do is we need to tell it which columns do I want to pivot down, meaning which columns have variables or have values, have data in them. And they shouldn't, column names shouldn't have data in them. They should just be the name of the variable. So all of our columns are 1960 through, I believe the max here is like 2020, 21, I want to say. Notice here that my numbers are kind of in this pink-purple color, which tells me that R is treating these numbers as numbers, not names. So for example, if I did like 1 through 10 and I ran this, I would get 1 through 10. Remember what I said a couple lectures back, column names cannot be numbers, or they cannot start with numbers at the very least. Neither can objects. So what we need to do, and you can see that R is not pleased about this either, it has put these backticks around these numbers to make sure that R doesn't treat these as numbers. So we need to do something similar. We need to put backticks around these numbers. And you'll notice once I do, it treats them as kind of a character, right? So it's saying take everything from this column to the column named 2021 and pivot it down. And let's see what happens when we do that. We get a data frame that looks much more similar to the type of data that we're used to using. And what are the benefits of doing this, doing things this way? Why do we use long format data? Let's think of our visualization process. We tend to put year on the x-axis when we want to make a line chart, for example. But here, there's not one variable for a year in the wide format that we can tell R to use, to tell ggplot to use. There's no year column here. There is information in these columns, and there's no way to tell ggplot, oh yeah, just plot it over the course of all of these variables. It makes it difficult to think about it conceptually. Here, we've gotten back to our 4-column way of thinking about things, and now we can just tell ggplot, yeah, all of your information about year is in this column. Let's also notice something else. First, the default columns that pivot longer will produce are called name and value. Now, I don't actually like that because we know what these columns are supposed to represent. So why don't we go ahead and rename these columns? This is another function that, just as it sounds, renames column names. So the way it works is you say, what's the new name you want equals what's the current name of the column. So this name column really should be called year. So let's go ahead and do that. Let's run that and see what we get. And sure enough, rename takes our column, the old one called name, and it renames it year. And in addition to that, I want to turn my value column into the electricity column. Wonderful. This is one way to rename these things, but we don't have to do it this way. In fact, pivot longer, why don't we take a look at the documentation? Pivot longer has some very interesting arguments, one of which is names to, and the other one is values to. So let's run this again and let's see what we get. We get a names column, and names to means what should you call this column? And likewise, we have a value column, and values to means what should you name this column? So let's say names to equals year, and I forgot a comma up here. And then I'm also going to say values to equals electricity. And if we run that, we get the same thing that we did, and we didn't really have to call the rename function, which is terrific. Kind of the easier that we can make things, the fewer functions that we can string together. In general, the better. So terrific. We've talked about wide format data, we've talked about long format data, and we've talked about pivoting from wide format data to long format data. Also keep in mind, if you choose for your final project a data set from the World Bank, much of their data is organized in this fashion. It's in wide format data. And so you'll end up using a lot of this backtick year notation that we use here. So if you go with that sort of data, this is the type of detail that you'll want to keep in mind. Okay, so we've done pivoting. Let's talk about iteration. And before we do that, why don't we create a set for ourselves and say, 1 through 20. And by the way, this is what the colon means. A colon means everything in between these two values, including these two values. So if I print out set, I'll get everything between 1 and 20, right? This is the object. That's the data that's in the object called set right now. If I do set plus 5, sure enough, it just shifts everything higher 5, right? That's how addition works. This is, in concept, how we do all of our manipulations so far, right? For example, why don't we put the pivoting that we just did there, and let's look at that. Why don't we do viz, and we'll mutate. I want to create a new column, and I'll say, you know what, year plus 2, and we'll just call that like new year equals. That's the name of the column, new underscore year, and I'm assigning data there, and all I want to do is just take year and add 2 to it, right? So let's go ahead and actually let's do something that makes a little bit more sense. Let's do minus 1960, which is the minimum year here, and in fact min year, right? So basically that means the first year of our data set will be 0, and every other year after that will be however many years it's been since 1960. So let's go ahead and run that. Whoops. Non-numeric argument to binary. What did I do wrong here? Right, so our year variable is actually a character variable. It's not treating it as a number, so we need to change its class from a character, CHR, to an integer, right? So let's say year equals as integer year. We'll just go ahead and do that, and then why don't we see what happens? Yep, okay, perfect. And pretty much what we thought was going to happen has happened, right? 1960 is year 0. Everything after that is a subsequent number of years from then. Why did we go through all of this? Well, if you think about what's happening behind the scenes when you use the mutate function, you can think about the fact that actually, eventually, the computer kind of needs to go row by row. And it needs to say, What's 1960 minus 1960? 0. Okay, put a 0 here. Next observation. What's 1961 minus 1960? It's 1. Okay, put a 1 in this column. It's doing this kind of iteration, but from our perspective, all we need to do is call mutate, and the R programming language will do that looping in a very efficient way. We don't really have to think about it at all. It's so far down in the hardware, down the stack of languages that R is built on, that it's super fast. It happens perceptively instantaneously for you. And it's fine that it happens this way, in fact, right? Because, you know, what happens in row 2 does not depend on what happens in row 1, right? It doesn't matter what the result of this operation is. The 1961 minus 1960 can happen at any time. Before we calculate row 1, after we calculate row 1, at the same time, doesn't matter. Not all operations are like that. And one of the interesting data types that has this quality is called time series data. So what is time series data? If you've taken a statistics course, you'll kind of know that time series data is data that is observed at regular intervals over some period. So for example, why don't we take a look? Why don't we take Viz, and why don't we filter down to country equals Canada. Canada. Whoops, I do mean double equals, thank you. Okay, great. And let's kind of put that in an object, and let's visualize what electrification rates look like in Canada. So as always, year goes on the x-axis, on the y-axis goes electricity, and then, you know, geom line, we can stop there, that does the job, but I like to have a point at each of my areas, and we take a look, and that's that's not helpful. That's not helpful at all. Maybe let's look at a different country, and actually I want to call this something else so that I don't have to kind of keep overwriting stuff. Nope, Egypt's name is a little bit longer than that. Morocco, is that how you spell Morocco? It is, thank God. Okay, and in fact, why don't we use a scale argument, scale x continuous, to limit what part of the chart that we're looking at. So I don't know, I'm going to say limits equals from 1990 to 2020, because it looks like that's where the data is, right? I can't forget to put C there. So let's run that, see what we get. Okay, this is time series data. Whoops, I put geom line twice. I don't need 2 lines. Okay, there we go. This is time series data. Time series data is kind of looked at in a consecutive series, right? Now, we're just observing this data, but in fact, we can simulate our own time series data. And in fact, sometimes we might want to. And when we do that, we're going to have to wait for all previous time periods to have been calculated. So what do I mean by that? First off, let's look at the general syntax of an iterating loop, which is called a for loop. So for loop. And it's going to start with for, open parentheses, I in 1 through 10, close parentheses, open curly braces, and I'm going to say print I. What's going on here? Before we run this, let's see what's happening. First off, I, think of it as like a temporary object, right? So this is just going to take these values one at a time. And here I've said, I want you to go 1 through 10. And so in order, I is going to take the value of 1, and it's going to do whatever happens in here. Print means put it in the console. So in loop 1, I goes, oh, I see, I'm 1. What should I do with that? Oh, print out 1 to the console. Done. Hit the end of the loop. Let's start again. Are we at the max yet? Are we at 10 yet? No. Okay, now I'm 2. Now do what? Oh, print 2 to the console. And it'll go like this again and again and again until it's done with 10. So let's see what we get here if we print it out. So it prints out every integer from 1 to 10. Right? That's what a for loop is doing. That's the general concept of a for loop. Let's go back to kind of our time series data. Let's say we start at 0, time series, and I'm going to say we start at 0. And what I want to do is at every step, I want to start from my previous step, and I want to add, basically I want to take a random step. So if I want to generate some random data, I'm going to do R for random, and I want to take my random noise from the normal distribution, R norm. And you'll see there are 3 arguments here. N means how many values do you want? I want 1. Mean means in the aggregate, what is the average of your normal distribution that you want to take a value from? I'm going to say 0. And SD is what's the spread of your normal distribution that you want a random variable from. So let's run this a few times and see what we get. Okay, that's a good one. Nice. Right, we ran it a bunch of times, and if we did this hundreds of thousands of times, we would find that the average is 0 and the standard deviation is 1, right? So we have a function to create some random noise. Okay, if I start at 0, I want to see what happens to this value after 10 loops. If I go through 10 times and I add a little bit of random noise every single time, what happens? So let's go back to our for loop right here. Right? I like this for loop. For loops are nice. We instantiated our time series object. And in here, what I really want to do is just add new values onto time series. So I'm going to say time series equals C, meaning I'm putting things together, whatever the existing values are in time series, plus whatever my kind of new value is, right? So let's think about for a second what my new value is. Why don't I create a new object called noise? And we know how we're going to calculate our noise, so let's just put that there. Now, what I need is to know what my next value is. And my next value is my last value plus noise. So my value is going to be time series at I minus 1 plus noise. And in fact, now that I think about it, I need 2 through 10 because I already have number 1. We're starting at 0. That's number 1. All right, let's go ahead and run this and see what we get. Whoops, I forgot to put value in here, right? So here what I want to do is I want to take everything that's already in time series and I want to also add value to it. Okay, let's look to see what we get in time series. Interesting, very interesting, right? In fact, why don't we put this into a data frame? In fact, I'm going to use an argument called tibble, which creates a data frame. And I'm going to say the index is 1 through 10, because we know that's what's going to go on our x-axis. And the values are in time series. And if we run that, we get these. Why don't we go ahead and put this in time series data frame. And let's visualize what we've got. Data from time series df. As usual, on the x-axis, we're going to put our time variable, which in this case is called index. You can see that on line 39. On the y-axis, we want to know what the value of our variable is, and here's where we put our time series. And then as we do with all time series, we're going to do a geom line and a geom point. Great, right? And we don't have to stop here at 10. We could go like 50 or 100, right? So why don't I, instead of manually saying I want to go from 2 to 10, why don't I just say I want to go from 2 to however many iterations you put here. Iterations, whoops. And likewise, when I update my data frame, I need to tell it you need 50 rows now, right? You don't just need 10 rows. Whoops. And then let's go ahead and plot that, right? So sometimes random numbers go down, sometimes random numbers goes up. That's, kind of the nature of randomness. What's important to note is that we could not have done this in the way that we do our regular mutations with dplyr. There's no way for us to kind of look back at the previous value before it's been calculated. When we look at things like this on line 19, it doesn't matter what order we do our calculations in. They can be done in any order. It's not dependent on the previous value. For loops are really useful when we want to do calculations that are dependent on a previous value. And here you've seen a very simple kind of implementation of let's generate some time series data, let's put it in a data frame and let's visualize it. Okay, so we've done a fair bit of iteration right now. That's not a super simple topic to look at, but it's important that you kind of understand that, right? Next, we're going to talk about functions. And in fact, when I look at all of this stuff, I don't want to have to do this every single time. This is a lot to kind of go through. I got to remember to type in 50 here, and then I got to highlight all of it, and then I have to run all of it. I don't really want to do that. I just want to be able to call something like time series creation. Okay, but actually, before we do that, because there's a lot of complicated code, why don't we see what a much simpler function might do? So I'm going to call this function divide by 5. This is the name of the function, and we're going to assign to it just as we assign data. But instead of assigning data, we're going to say function, and I'm going to put an X in here. And that tells R, I'm going to pass in some data to this function. And then I'm going to open a curly bracket. And I'm just going to say, okay, whatever I give you, X, divided by 5, and put this in an object called temp. And then I want you to return temp for me. And if you'll notice, this showed up in our environment, but it showed up in the functions part of the environment. We didn't save any data. We didn't create anything. Why don't we try and run our function? Divide by 5. I'm going to put 10 in there, and we get 2. If I put other numbers in there, sure enough, I mean, you'll have to check that one for yourself. I don't know if that's correct or not, but, no big deal. If we divide by 5, these are the numbers that we get, right? Actually, that one doesn't look right. It ends in a 3 and we're getting a 5, but whatever, no big deal. In general, we can simplify a lot of these repetitive actions that we need to take by putting them in functions. So in fact, why don't we put all of this in a function, right? There are things that I might want to change from one to another. Like maybe I want one that has 70 iterations and not just 50. Maybe I want one that has 3 iterations. Well, we can do that, right? So why don't we say time series creation? We're going to create a function, and this time instead of naming my data X, I'm going to say iterations. This is the input that I'm going to put into this function. And all I'm going to do is, we already did all of this work. Why don't I just copy paste all of that, put that in there, and instead of putting 50 here, I'm going to say put iterations. Whatever number you put in here, just use that. And I'm going to keep that, and I'm going to say, okay, terrific. And one last thing, since we don't have return, this function will run, but it won't give you back anything. So let's say return G. I want you to print out the plot. So let's try that. Let's do time series creation. And I want 7 iterations. Cool. I want 100 iterations. I want 1,000 iterations. That one takes a little bit more time, but you kind of get the point, right? You should get what's going on here. Every time I run this function, it runs all of this. And I didn't, well, not this part, all of this. And I didn't have to go back and redefine this and highlight all of this and run it. All I had to do was create this function. And when I want something different, I just run it like that. And it gives me the output. I wrote the code once, and now I can run it a million times if I wanted to, and it really simplified all of my work. So that's really the power of functions. You can put repetitive work in functions, and you can help automate it for yourself. I'm not sure if you'll use that in this class, but in general, it's very helpful to understand how functions work and how you can use them. Okay, last thing we're going to look at is regular expressions. Regular expressions are a way of extracting information, regex, extracting or matching string information. So I'm really just going to go based off of the example that we used in the lecture and kind of give you a second example of that, a very similar example, because you're very likely to run into examples like this. So I'm going to call this country year. And we're going to say Botswana 2020. And we're going to say 2019 Canada. And we're also going to say United 2016 states. Now, this is exceptionally dirty data in the sense that whatever dingus put it together, put the year in different parts of each of these strings. So, for example, let's say I wanted to extract information about what year we're referencing in each of these strings. I couldn't just tell it, take the first 4 characters, or take the last 4 characters, or take the middle 4 characters, because the position of year in every single one of these is different. For Botswana, it's at the end. For Canada, it's in the beginning. And for the United States, it's in the middle. Instead, what we need is some function and some way of talking about strings that generalizes patterns of text. So we're going to use the function called string extract, which, as it sounds, is going to extract information for us from strings. So the first argument is the string. What string are you interested in? And we know that we're going to look at country year. And then it's asking us for a pattern. Whenever you start a regular expression, it starts with square brackets, and they need to be in quotation marks. Then we need to ask ourselves, what exactly are we looking for? If I just want the year, I kind of want to extract everything from 0 to 9. Let's see what happens when we run just that. What this did was extract the first number that it found that matched this criteria. It said, okay, if this letter or this character is anywhere between 0 and 9, I want you to pull it out. That's helpful, but we know that a year has 4 digits in it. So after this little square, we're going to open up a curly bracket, and we're going to say, look for 4 characters in a row. And if we run that, we correctly get our year. Likewise, we're not limited to doing numbers. What if we wanted to kind of do the opposite thing? What if we just wanted to extract the country names? Well, in that case, we don't want any numbers. Instead, what we want is any lowercase letter or any uppercase letter. Now let's run that, see what we get. Cool. So since we kept the 4 in there, we're getting the largest first string of 4 letters. We want more than that. We want strings that are at least 1 long, but can go up to however many. Right. So that worked for 2 out of the 3, and we're not going to dive too deeply into how to get the United States to work properly. But suffice it to say, I leave that as an exercise for you, because Regex is a rabbit hole that you can absolutely fall down. Suffice it to say, we've more or less successfully extracted country names, right? Yes, United could be UAE, but like I said, go look up other Regex tools. If you're really that interested, you probably won't need to know any more complexity than this for this class. You definitely won't for this class. So these are regular expressions, right? Ways of talking about strings and matching patterns that make your manipulation of those strings and like dirty string data much, much easier. Okay, so today we talked about 4 things. Pivoting, which is really central to a lot of data analysis. You need to get your data into a long format before you do any type of analytics. So this is going to be usually one of the first things that you do. We also talked about iteration. What do we do when we need to do a function that relies on the previous iteration's output, right? And we used it in the sense of time series data. We kind of generated our own time series data. Then we looked at functions. How do we kind of automate repetitive tasks in our code? If I know I'm going to have to do the same thing again and again and again, rather than highlighting it all and running it again, I'll just make a function that does the same thing. And lastly, we looked at regular expressions, which are a method of analyzing and pattern matching to strings. So at this point, we only have 1 lab left after this one, and it will be spent doing markdown stuff. At this point, you should also really be thinking seriously or settling on whatever data set that you're going to use for your final paper, your final analysis that you're going to do. Make sure to come talk to me once you think you've settled on a data set. I want to make sure that your guys' data sets aren't really overlapping, because helping each other is very wonderful. It's terrific. I encourage you all to do that, but I don't want to read 15 or 20 of the exact same paper. So I'm really hoping that you guys will all choose different data sets, and I'm going to make sure that we don't have any overlap in those data sets. So the sooner you come talk to me and lock in your data set, the better. So if you have any questions, as always, please feel free to reach out, and otherwise have a wonderful day.